Welcome back everyone to the Hello World Guy, and this is episode number 10 of the 3D platformer series. And in this video we are going to finish our enemy here and make it chase the player because currently it can only detect the direction but cannot actually chase the player. So we will implement that. So I'm just going to select my enemy and I'm going to double click the script to open it up in VS Code. And in here what I'm going to do is I'm going to go in the I'm going to basically just go under the update method, in which we call this chase player method. And in the chase player method, but you can see that we calculate a direction, and let me just increase the size font here. And after calculating the direction, we set our rotation to that. We use the look rotation method to find out the rotation. And what we are also going to do is we are going to go transform dot position plus equal dir multiplied by our speed multiplied by time, the delta time, to make it frame rate independent. And yeah, that should actually work. So if I go under Unity now and then compile, and if I go ahead and hit play now, what you should see is that by default the enemy does not wake up because we are out of the range, and as soon as I go in the range you can see it wakes up, but it's still not chasing me. And the reason is that we have set the speed of the enemy to 0 here. So if I increase the speed, then you can see it is moving, but it is moving in the opposite direction, which is kind of really surprising. It should be moving correctly, and it is moving in the opposite direction. Does not make much sense. So yeah, why is that happening? It shouldn't happen. Now what if after setting the rotation we just try to say transform dot forward instead of the direction? Maybe we are calculating the direction wrong. Let me just say player dot transform dot position minus transform dot position. Let's check that out, and let's go to Unity. Let's compile, and let's try to hit play, because I think that the direction formula was incorrect. It was calculating inverse direction. And yeah, let's see. Okay, no, it's not chasing us at all. Okay, it's working, but now the direction, now the rotation is incorrect, but it's moving correctly. Well, that is surprising, certainly. But the actual reason that the rotation seems incorrect, it's actually not incorrect. The reason is that okay, that's not the reason. So yeah, we will have to find out what's causing this problem. But the actual reason, okay, I just found it out, is that the z of this glasses is negative, so the glasses are on the incorrect side. The actual enemy is still working. So if I select that, move the glasses to the other side, which is the correct side, positive. If I do that, then you can see that I can go under here and the enemy now starts to chase me. And yeah, that's pretty awesome, and he pushes me until I fall down. Okay, it does not allow me to fall down either because it's currently pushing me. But yeah, we will have to make it a little better so that it actually has an acceptance radius, but the basic idea is working. Alright, so now implementing the acceptance radius is really simple. You can see I have added in a private float here for the acceptance radius as a serialized field. And what we will do is we will basically check here in the actual method. When we are moving towards the player, we will check if our and we will just check the distance between the players by using this formula. And we are checking if this radius is less than or equal to our actual acceptance radius. So if I do that, and then I think that's pretty much enough. So this should only execute if it's within our acceptance radius. And we can also draw the acceptance radius. By the way, we can draw yet another radius here, another sphere here, which has the acceptance radius as the radius. And let me just check out the if there is an option for changing the color. I doubt if there is. There is an option, I know that, but let's just try to see how well it goes. Actually, let's change the color of that first, because it will cause because these will be indistinguishable if we don't do that. Alright, so all you need to do to change the color of the gizmos is say gizmos dot color is equal to color dot let's say green for the actual range. And then for the acceptance radius one, we are going to make it red. As simple as that. Let's go under Unity and let it compile. It should not take that long. By the way, you can also turn on gizmos in the game mode by pressing this icon. As you can see, that turns on the gizmos. And if I go in here, you can see this is the green radius, which will be our radius for when we actually determine where our enemy will detect the player. And if I go under here and I change its change its acceptance radius. This is the radius that the enemy will stop the player, stop, if it is this away from the enemy player, then it will stop moving. So I'm just going to keep it at 1 because I think that's pretty awesome. Oh, but before we actually do that, there's a small change. We actually need this to be greater than or equal to the acceptance radius and or less than. So if I make that change and then I go to Unity, my game is already running, it seems. Then you can see that the effect already happens and the enemy moving towards me, but it does not stop. Okay, let me just rerun the thing. Acceptance radius 1. Okay, let's check how well it goes. Let's just increase the acceptance radius to see it a little better. Alright, so let's go to the enemy and you can see it's moving towards me and it does stop at the correct radius. And you might want to make it something like 1.75, and once you do that you can see that this is what the enemy stops, this is the distance that the enemy stops, and that's pretty awesome. If you change it to something like 1.5, then the enemy gets pretty close, but I think yeah, you can set it to whatever you like, it doesn't really matter. I'm just going to set it to 1.6. Alright, so now we need the enemy to actually damage the player. So for that, what we will do is currently we will just go under our enemy and we will check if it's greater than or equal to, and if not greater than, and let's just say greater than, that means that our player is close to the enemy, and that means that we probably should attack the player. So also we are going to say we have got player here, so I'm going to just say player dot die. Just going to call that method, and that's really simple. Oh, by the way, in the die method, instead of just destroying this, we are going to say this dot enabled is equal to false, and then we are going to say rb dot enabled, rb dot actually let me just say type. Okay, it's not type but it's called. Okay, so we are going to we will have to make it so that this rigid body does not impact the player anymore. So for that, if I just select my player, and then you can see that the rigid body has got, okay, so we are just going to make the rigid body kinematic. So rb dot kinematic, if kinematic is equal to true. All right, so yeah, this should pretty much work. So let's go on our Unity and wait for it to compile, and okay, and let's try running this and see how well it goes exactly. And this should actually work. So if I go near the enemy and I do not manage to escape from it, then you can see that the game is over. Now I can no longer move and it's working. So yeah, this is pretty much it for this video, and I will see you in the next one, in which we will add another kind of enemy. It's going to be really interesting. I'm planning on something like a rocket launcher. So yeah, I will see you in the next video. Make sure to like and subscribe, and bye.